Next ones, they are working with fractions that are under the square root. And basically, the same thing holds true. Since the whole thing is under the square root, I could think of that as one big problem under the square root. So I would have y to the 10th, z to the 9th over 2 times 8x to the 7th over x to the 5th, y to the 6th, z to the 9th, like it was under one big square root and instead of two separate ones. Well, when I'm multiplying fractions, I can go ahead and do some reducing. So I can say, oh, 2 goes into here once and into here 4 times. I've got a y to the 10th and a y to the 6th, so I can take out 6 of them, which leaves me y to the 4th. I've got a z to the 9th and a z to the 9th. Those are just going to cancel each other out. And I've got an x to the 7th and an x to the 5th. If I take out 5 of them, I get an x squared. So under my square root, I'm going to have 4y to the 4th and x squared. There's nothing left on the bottom because everything canceled out there. Now I can simplify that. Again, in this case, all of those things are perfect squares, so I can just go ahead and take my square root. The square root of 4 is 2. Square root of y to the 4th is y squared. And the square root of x squared is x. And if you had 2xy squared, it'd probably be even better, but it really doesn't matter which order you have your variables in. So I probably really didn't need to rewrite that as one big square root. Again, they want to get across on the next one here that even though these are two separate square roots, I could write it as one big square root and put it all together. So since everything's under square roots, I would treat it just like the whole thing was under one big square root and go ahead and do my reducing. So what can I do with number 5? Three goes into 27 9 times.
W goes into 6. 4.
I'm going to take out 4. And there's 2 left over, exactly.
And then there's going to be 6 left over on the top.
I'm going to take off 7 y's, and I'm going to get y to the 6th on top.
And then z is just completely...
Z's cancel out altogether. So those are still under the square root. We have 9w squared and y to the 6th, all under my square root. And again, all of those happen to be perfect squares, so I can take the square root of all of those, and I would get 3wy to the 3rd. And number 6 is going to be the same kind of thing. So if I reduce that one down, what can I do with that one?
9 goes into 81 9 times.
9 goes into 81 9 times.
W to the 3rd and w to the 5th. There's going to be 2 left over on top.
So I get w squared on top.
There's going to be y in the 2nd on top. And then z's cancel out.
Z to the 8ths cancel out. So I have the square root of 9w squared y squared, which again are all perfect squares. So if I take my square root, my answer would be
9wy.
not 9wy, 3wy. That's what you meant.
Yeah, that's what I meant.
3wy. So not too bad, right? The next ones are going to talk